Hello everyone, what I am going to talk about today is our paper entitled Flame Recognition System using YoLo. My objective today is to present a management system that uses drone-mounted cameras combined with object identification and live broadcast systems to assist disaster relief. I'll start with first, I will talk about the drone development background along with AI. Then, I will look at the background review and related works. Next, I will discuss about system architecture and environment development. Following, the experimental results, and finally summarize the paper in conclusion. Let me begin by explaining about drone history. The history of the drone's development have ranged from the military use that the US military used to fight thousands of kilometers to the enemy to the civilians today. It has far exceeded the larger and wider range of applications. Because the cost of various electronic parts has been greatly reduced, the performance is far from beyond the past. The threshold for consumer-grade drones is increasingly lowered. In addition to the common handheld remote-controlled aircraft of the general public, it is also commonplace to take pictures of unmanned aerial cameras in major gathering occasions and TV programs. In view of the ability of unmanned aerial cameras, due to the limitation of terrain, many government units have used unmanned aerial cameras to cooperate with firefighting units to carry out various rescue operations. In the execution of duties, the situation that the mismatch of information causes fire safety concerns has always been an insurmountable threshold for rescuers. This study uses transfer learning to implement a live broadcast system for UAV object identification, providing real-time information on the fire scene. This research solves the problem that drones on the market need to be equipped with infrared thermal sensors to determine the source of fire. Our paper combines unmanned aerial cameras and object detection to assist disaster relief through artificial intelligence object recognition technology. Microsoft Azure platform is used as a development system platform. OpenCV and YoLo are implemented to provide image processing and model recognition. The system will perform image recognition on the real-time transmitted images, detection and classified objects. Before we conduct the research, we confirmed several theoretical methods in the related works, including RTMP, HLS, HLS Stream, and YoLo. First, RTMP or Real-Time Messaging Protocol, originally developed by Macromedia to transfer streaming audio, video and data between flash players and a server via the Internet. Macromedia was later acquired by Adobe Systems. This agreement was established on the basis of the TCP protocol or polling on top of the HTTP protocol. Second, HTTP Live Streaming, abbreviated as HLS, is an HTTP-based streaming media network transmission protocol proposed by Apple. It works by first cutting the entire media stream into small HTTP files, and downloading only a small part each time. When the media stream is playing, the client wants to download the same resource from many different alternative sources, and download at different rates, allowing the streaming media session to adapt to different data rates. HLS only requests basic HTTP messages. Unlike RTMP, HLS can pass through any firewall or proxy server that allows HTTP data to pass through. Third, after passing JINX with RTMP module, we can convert the RTSP signal output by Python into HLS and display it on the web page. Because HLS can pass through any firewall or proxy server that allows HTTP data to pass, we don't need to install a special plugin and you can watch the live broadcast. Fourth, YoLo is a real-time object detection which classify or localizes the images. High-scoring regions of the image are considered detections. YoLo model has several advantages compared to other classifier model. The prediction system is based on looking at the whole image to predict picture by global meaning. This also allows predictions unlike systems like RCNN that allow thousands for a single picture for a single network evaluation. That makes it incredibly fast, more than 1000x quicker than RCNN and 100x quicker than short RCNN. We also examined several papers that related to our research. Rivera et al. proposed a modular system for human detection and geolocation. The study implemented a structure that can find possible human survivors in areas affected by disasters, including 2 shots and a geolocation module installed on the drone. According to the results mentioned in the article, the thermal detection effect is the best when used in night operation. On the other hand, the data implies that the optical detection can also operate effectively during the day, and with nighttime deployment has higher accuracy than daytime deployment. Zak et al. Discuss about the method for real-time detection of people and vehicles for unmanned aerial vehicles or UAV, for aerial reconnaissance and surveillance. This paper proposes a method to automatically detect vehicles based on the use of multiple trained HAR classifiers and secondary confirmation in thermal imaging. In addition, a related method is proposed for human detection in thermal images combined with additional multivariate Gaussian shape matching. The results given indicate that vehicles and people are successfully detected in chaotic rural and urban environments under different conditions. Jitsidis et al. Proposed the use of unmanned aerial vehicles equipped with optical and thermal sensors, as well as complex image processing and computer vision algorithms to detect suspicious activities or prevent the spread of fire. This paper is mainly special. The reason is that the human detection process is suitable for high altitude and vertical shooting images, in contrast to most other similar works that consider lower altitudes and different shooting angles. This picture is the architecture diagram of the UAV target recognition system applied to the disaster relief scene. In order to be able to watch UAV images in real time, the environment part will build an RTMP streaming server, and the identification part will diversify the analyzed items. The identification part will diversify the analyzed items and add various dangerous items as the analyzed items to facilitate future rescuers to use this system, improve the safety of rescuers and facilitate the rescuers to quickly plan and discuss the rescue moving line. By setting Jinx as a web server, although Jinx is a lightweight server, the RTMP module written by others can also host RTMP streams, and then configure RTMP and HTTP HLS live broadcast protocols under Jinx configuration. The environment part uses the Ubuntu 18.04 operating system as the development environment, uses Python 3.6, TensorFlow 1.13.1 and Keras 2.2.4. Let's now turn to, the dataset used is from 2,500 flame and smoke images, with 1,250 flame and 1,250 smoke images, as shown in the picture. After collecting the dataset, we labeled all the collected images. The purpose is to clearly select the features to be learned. Each labeling of a picture will generate an XML file, which is the content of the label position of the picture. Move to the experimental results. We trained the flame and smoke pictures after labeling. The left figure shows the classification loss of the training model. Over 100,000 iteration and loss value dropped to 0.1. The right figure is the performance of the model in the video. It can be seen from the right picture that the model predict the fire by a 0.99 accuracy. I'd like to conclude by: first, this paper designs a UAV object recognition system that is applied to disaster relief sites. It can watch drone images in real time, helping disaster relief personnel to track the spread of fire and fire sources, and assisting in disaster relief. Second, compared with the past, the UAV needs to be equipped with an infrared thermal sensor to determine the source of the fire. This paper uses object recognition technology to assist disaster relief and improve the safety of disaster relief personnel. That brings me to the end of my presentation. Thank you for listening, your attention.